All right, guys, so far we've learned how to graph sine, cosine, secant, and cosecant. And so today we're going to talk about graphing tangent and cotangent. All right, so that's the goal for today. Let's go ahead and jump in here. So let's go ahead and do the same thing we did with the other ones. We're going to start off by just plugging in some numbers here. So let's say I want to graph this function here. And I want to get my answers here. And then we're going to see what the graph of that will look like. So negative pi over 2, that's down here. What is the tangent value at that point? The tangent value at that point is undefined. So that means we're going to have a vertical asymptote there, just like we had whenever we had secant and cosecant. Now what about negative pi over 4? What's the tangent value? The tangent value there is negative 1. How about at 0? What's the tangent value at 0 degrees? Or radians, I should say. That would be 0. How about at pi over 4? It's a positive 1. And then finally back up here at pi over 2, we have undefined again, so we have another vertical asymptote. And after that, if I just keep going around the circle, I'm just going to get a repeat of this pattern here. And so we can go ahead and graph this. So let me show you guys how to graph this. The number I'm plugging in for is the theta, so that's going to be like my x-axis. And we'll call this the tangent axis, if you will. It's kind of like your y value. So these are the angles that I'm going to put on my x-axis. Negative pi over 2, negative pi over 4, 0, pi over 4, and pi over 2. And just so you guys know, in degrees, that would be negative 90, negative 45, 0, 45, and 90. So you're noticing that, first of all, we're dealing with some different angles than we dealt with whenever we were doing sine, cosine, secant, and cosecant. So that's one important difference. With tangent, we're going to use these angles here, okay? I'm going to leave them just in radians for now. All right, so let's go ahead and graph. So at negative pi over 2, we have a vertical asymptote because the function's undefined there. At negative pi over 4, we're at negative 1. So I'll call that negative 1 and that positive 1. So at negative pi over 4, we have a dot there. And then at 0, we have 0. And then at pi over 4, we're at 1. And then finally at pi over 2, we have another vertical asymptote. Okay, now I'll show you what the graph of this thing looks like by connecting these dots and staying in between the asymptotes. Now, I'm not going to be too picky about how you graph these, although I've just noticed students have a really hard time graphing these. So it's kind of okay, honestly, if you just connect these with a straight line. Although it's not really straight. But what you need to do then is have it curl up and get flat against that asymptote and flat against that asymptote. I'll accept that, okay? But now technically how you're really supposed to graph these is by the following way. So the way you connect these dots is you kind of make an upside down curve here, concave down, and then a concave curve up here. And then you go up to the asymptotes. So that's really what it looks like. This connecting those three dots is not a straight line. It's really supposed to be concave down on one side and concave up on the other. And then you go up against the asymptotes. But that's what tangent looks like. Now, if you were to graph on the other side, it would just repeat. So it's going to look like this over here. It'll look like that over there. It just kind of keeps going on and on forever after that. Okay? So a couple things to keep in mind when you're graphing a tangent function. First of all, we're going to use these angles. Or if you wanted to do degrees, it would be negative 90, negative 45, 0, 45, and 90. So we're going to use these angles instead of the ones we were using for the other functions. Also, the shape. Okay, so this tangent basically looks like this. Let's go ahead and do a cotangent graph now. We're going to use yet another different set of angles for cotangent. So, cotangent at 0 is undefined. At pi over 4, now I'm just going to tell you the answers for this, because really to do these, you would have to translate it into tangent, right? So if I asked you to find what's cotangent of pi over 4, technically, you guys know that means we would do 1 over tangent of pi over 4, which is 1 over 1, which is 1, okay? And you'd have to do that for all of them. But just for the interest of time, I'm just going to go ahead and tell you what these are, okay? So at pi over 2, cotangent would be 0. At 3 pi over 4, cotangent will be negative 1. And at pi, cotangent is 0. I'm sorry, not 0. Cotangent would be undefined at that point. And it's just going to repeat after that. So let's go ahead and graph this one. Once again, this is my theta axis, and this will be my cotangent axis here. And I'm going to plot these numbers on my x-axis, or my theta axis. 1, 2, 3, 4. I think that'll be it. So we have 0. We have pi over 4. We have pi over 2. 3 pi over 4. And then pi. So for cotangent, we're always going to use those angles. So now it's starting to get to be a lot of stuff to remember, but we'll just have it written down, and I'll have a summary of it on here for you guys too later on. But for sine, cosine, secant, and cosecant, we use one set of angles. For tangent, we use another set. And then for cotangent, we use another set. And that's just because these functions have different periods. They all start and stop their cycle at a different space. And so to get a full picture, we have to use the correct set of angles to get that. All right. So now we're ready to graph. So at 0, cotangent's undefined, which means that it's going to have a vertical asymptote at 0. So I'll do a little brown dotted line there. At pi over 4, cotangent equals 1. So I'll go up 1 and put a dot here at pi over 4. At pi over 2, cotangent equals 0. And then at 3 pi over 4, cotangent equals negative 1. And then for our last one, we have another vertical asymptote. Now, cotangent has a very similar graph to tangent. The only difference is it's backwards. So from here to here, we go concave up, concave down, and then squish it in. And there it is. So there's our graph. All right, so that's what cotangent looks like. So you'll notice that it looks a lot like tangent. It's just backwards. Tangent was this way. Cotangent faces the other way, okay? Another difference about cotangent is the different angles. Now, something that's a little bit easier to see is that cotangent and tangent both go up by 45s. So like this is 0, this is 45 degrees, this is 90 degrees, this is 135. So both tangent and cotangent are spaced, their angles are spaced apart by 45 degrees if you look at it in degrees. It's a little bit hard to see that in radians. Tangent works the same way. We go back here. This is negative 90. If you add 45 to that, you get negative 45. If you add 45 to that, you get 0. If you add 45 to that, you get 45. And if you add 45 to that, you get 90. So the other graphs that we've graphed so far, they were spaced by 90 degrees, but tangent and cotangent are spaced by 45s, and that's because they have a shorter period. So here's our graphs of tangent and cotangent. On these graphs, take note of 3 things. Where are their vertical asymptotes located? That's the blue dotted lines. Also, take note of the angles that we use to graph it. And then notice the direction they're going. Okay? So that is tangent and cotangent graphs. Now, as you guys may notice here, let me go back for a second. These graphs don't have a midline, but they do have a midpoint. They don't have a midline, so we're not going to draw a blue dotted line going this way, but they do have a midpoint, a point in the middle. Now, to get from your midpoint to your next point, you go over 45 degrees, or pi over 4 radians, and then up 1 space. Or you go left pi over 4 and down 1 space. Okay? So Now for cotangent, it's the other way. We go left and up and then right and down, but it's still pi over 4 and 1, pi over 4 and 1, right? So keep that in mind as we move on to the next segment here. So once again, the A is your amplitude. It will stretch your graph. So if you multiply the tangent graph or the cotangent by A, if that basically is going to tell you how far to go up and down. So you guys know how, if we're at our midpoint, I'll label that M. We go over pi over 4. Well, if you multiply the function by A, instead of just going up 1, you're going to go up A spaces because it will stretch it. If A is greater than 1, it's going to stretch it so that it gets longer. If A is less than 1, it's going to be shorter so the graph will get a little bit flatter. And you also go this way. So A basically tells you how far to go over and up. The K is going to tell you where your midpoint is. For sine, cosine, and secant and cosecant, that was our midline. But for tangent and cotangent, we're going to say that's where our midpoint goes. It tells you how high up to put your midpoint. Okay? So instead of calling that M, now I'm going to call that K. So here's some pictures I would encourage you guys to add to this slide if you haven't already. K goes here. Next, actually, let me be even more specific than that. For tangent, your midpoint is going to start at 0 and it'll go up K spaces. So that's where your midpoint will be located. You're going to go over and up A spaces, and you go over and down A spaces. All right, that's for tangent. Now for cotangent, it'll look like this. Your midpoint will be located at pi over 2, comma K, because the middle of cotangent is at pi over 2, whereas the middle of tangent is at 0, and they will both be at a height of whatever the K value is here, right? And then for cotangent, we go left and up A, right and down A. So that'd be a good picture to add to your graph there. All right, so that being said, I think we're ready to talk about how to graph these things. So if you want to graph tangent and cotangent, the first thing you need to do is set up your graph with the correct angle values on there. So if we're doing tangent, then put these angles on there. If you're doing cotangent, then put these angles on there. Next, sketch your asymptotes at the first and fifth values. So for tangent, you're going to put a vertical asymptote here and here. And for cotangent, you'll put a vertical asymptote here and here. So sketch asymptotes at the first and the fifth theta values. 2, plot your K value in the middle. So for cotangent, the K goes here. And for tangent, the K goes there. And for cotangent, the K goes at the 90-degree angle. Or you could say pi over 2 if you wanted to, if you wanted to do radians. Okay? So plot the K value at the third theta value. And then finally, plot the other 2 points using your vertical stretch factors. So from K, you're going to go over 1 space and then up A spaces, over 1 space and down A spaces. This is for tangent. For cotangent, you do the same thing, it's just in the opposite direction. Okay, so we'll do a couple of examples to bring that to life for you here. So let's do our first example set. Okay, so I would encourage you guys to have out right now look at the steps. What does the first step say when you're trying to graph a tangent function? The first step says make sure that you set up your graph with the correct angles. Okay, so what are the angles for tangent? On the steps that you guys wrote down, the angles that we use to graph tangent are -90, -45, 0, 45, and 90. So that's step 1. Okay, take a look at step 2. What does step 2 say? Step 2 says that we should put vertical asymptotes at the fifth at the first angle value and at the fifth angle value. Now, what does step 3 say? At the third angle value, that's the one in the middle, at the third angle value, we're going to plot our k value, which is -1. So where would that dot go? So at this angle, we want to go down 1 on the axis there. And so we're going to put a dot right there at that point. Okay, now take a look at your, what is that? The last step. According to the last step, what do we do? Well, you're going to use this number here. That's your amplitude. And that tells you how far to go up. So we're going to go over 1 space, and then we're going to go up 2 spaces. Okay? So now where do we start at when we do this? We start at the k value, this dot that we put right here a second ago. So we're going to go over 1 space, which is really 45 degrees, and then we're going to go up 2 spaces. So over 1, up 2, 1, 2. We put another dot, and then we go over 1 this way, and we go down 2 spaces. So over 1 and down 2 spaces. This side should be slightly concave down. This side should be slightly concave up. And then we just stretch it out towards the asymptotes after that. And there's our tangent graph. So there it is. So you set up the graph first with the correct angles. Then you put on your asymptotes. Then you plot the k value. So at the middle angle, you go up or down this far. And then starting from that k value, you go over and up this much, and the other and left down, and then down that much. And you get your graph. And of course, as you guys know, tangent just repeats, so it's going to look like this as it keeps going on to the left and right forever. All right, let's do another one. So once again, go ahead and look at your steps and see if you guys can figure out what to do. Now this one they want us to use radians instead of degrees. So let's do that. Let's use radians instead of degrees. So I would encourage you to pause the video here and see if you guys can correctly set up your graph. All right, so the graph for cotangent to be set up appropriately starts at 0, and then the rest of them are over here on this side. And if we're going to use radians, then it's going to be pi over 4, pi over 2, 3 pi over 4, and pi. Now, if you guys put the degrees there instead, you might have put 45, 90, 135, and 180. You're not wrong. It's just that I want you guys to know how to do it with both radians or degrees. Okay? All right. Go ahead and pause the video here and do step 2. Step 2 is to plot the vertical asymptotes at the first angle value and at the last angle value. All right, go ahead and pause the video here and do step 3. So step 3 is to find your k value. Now there's no k value here, so that means it's 0. So that means at the third angle value, which is pi over 2, the one in the middle, I'm going to go up 0 spaces, which means I'm going to be right on the axis in this case. I'm going to put a dot right there. So at the third angle, in the middle angle, we're going to go up none. So it's at 0. All right. Now, cotangent, remember the direction it goes. And this is your A. So see if you guys can figure out the last step. I'm going to pause the video here and give that a try. See what you guys get. All right, so here's the last step. So if I were to call this 1 and this -1, then half would be like right about here, and -half would be right about here. So now with cotangent, when you go over to the right 1 space, you're going to go down to the half. So we're only going to go down a half instead of a whole step. And then I'm going to go over 1 this way and up a half step. And there it is. So we're going to be slightly concave up here, slightly concave down there, and then that's our graph. And you can once again draw some more on this to the left and right of it that would look roughly something like that. Okay? And so that's graphing tangent and cotangent. So here's a student practice for you here. So Take note of the fact that for the first one, you use the degrees, and for the second one, use some radians. All right, so pause the video here, try both of these. When you unpause it, you will see the solutions. Okay, guys, so here's the answers to those student practices. Some things to take note of: your tangent graph should have had 2 spaces to the left and 2 spaces to the right. Make sure you have your vertical asymptotes there. Is your midpoint at 0, -1? That's where it should be. And the other 2 points. Your other point should be over 1 space and then up 3. And the other one should be over 1 to the left and down 3 from there. So this one should be at -4. And this one should be at +2 since we're starting from down here. And then, of course, this is what the shape should look like. Now for cotangent, you should have your 4 angles here off to the right side. You should have your vertical asymptotes at the first and last spot. Your midpoint should be at the middle angle here and down 1 space at -1. And then cotangent goes in this direction. So you go over 1 and then up a half and over 1 and down a half. So this point should be at -1/2. This point should be at -1.5. And then there's your shape of your graph. So those are the things you want to look for as you check your answers there. All right. Let's go ahead and move on to our next section here. All right, guys, so we'll talk about horizontal and vertical reflections now and how they affect the graph. So first of all, anytime you have a function with a negative on the outside, it gets flipped upside down. And anytime you have a negative on the inside, it flips it horizontally. That's something we haven't looked at since last semester, but there it is. So those are horizontal and vertical reflections. So if you multiply a negative on the outside, flips your graph upside down. And if you put a negative on the inside, it flips your graph horizontally. Okay, so let's go ahead and see what effect that's going to have on our trig functions that we're graphing right now. So first of all, let's talk about sine. So this is what a regular sine function looks like over here. And in that case, you start at the midline, and then you go down. Right? So we start at the, I'm sorry, you go up. So I'll fix that really quick. So we start at the midline and go up. But what if we take our sine function here, and I have a negative in the front? Well, that flips the graph upside down. So now, as you guys can see, it starts at the midline, and then it goes in a downward direction after that. This one went up, that one goes down. Okay, so what about here? What if I have a negative on the inside? Well, we said that flips it horizontally, so now I'm going to flip it this way. And finally, what if we do both? What if we flip it upside down and flip it horizontally? So I'll flip it upside down, and then I'll flip it horizontally. Let's go ahead and see what each of these do. Well, all of them still start at the midline. This one goes in a downward direction after the midline. This one goes in an upward direction after the midline. So let's add these notes to our chart. All right, so there's our summary. Now, I don't know, do you guys want to take the time to memorize this or write it on a flashcard or something? Or maybe just do what I do and remember the original one and then just flip it in your head and you can kind of see which way it's supposed to go. It's up to you how you want to commit these to memory. But there you have it. Let's go ahead and take a look at cosine now. All right, so with cosine, this is what the graph usually looks like. But in this case, if I put a negative on the outside, that's going to flip it upside down, so it'll look like this. Or what about if we have a negative on the inside? If I flip it horizontally, then it looks like this. So it kind of looks like the original one, right? Finally, what if I do both? What if I flip it upside down and flip it horizontally? Well, let's see. I'm going to flip it upside down first, and then I'm going to flip it horizontally. And this one ends up looking a lot like the one that just has a negative in the front. So there's that. So now you'll notice that for the original cosine function, we start at the maximum and then we go down. For this one, we start at the minimum and we go up. This one's a max and down, and this one's a minimum and up. So once again, you could either put this on a flashcard or you could just figure it out like I do, but I'll add the notes down here now. All right, so there you go. So that's for cosine. Let's go ahead and take a look at tangent next. So for tangent, what do you guys think this would look like if I flipped it upside down? Well, let's see. All right. What if I were to flip it horizontally? What if I were to do both? What if I took tangent and flipped it upside down? So that's been flipped upside down. And now I flip it horizontally. There we go. All right. So this function seems to be going in an upward direction as I move to the right. So we would call that increasing. This one seems to be moving in a downward direction. So we would call that decreasing. This is also decreasing. And this is increasing. So once again, these are all the different ways that tangent can look based on the reflections we subject it to. All right, let's go ahead and take a look at the last one, cotangent. Now, typically, cotangent looks like this, which is pretty much like tangent. It's just backwards from the regular tangent. So if I take my cotangent and then flip this guy upside down, it looks like a tangent now, doesn't it? Okay. What if I take my cotangent and I flip it horizontally? Looks like a tangent also. What if I take it and do both of those things? Flip it upside down and flip it horizontally. Just like that. So there you guys have it. So with cotangent, it's actually going to be the opposite of what tangent is. The regular tangent is increasing, where the cotangent is decreasing. And then each one of these ones are increases. And we're back to a decrease here. Okay. So those are all the ways that these reflections can happen and change the way the graphs look. So let's review now. Now that we've learned how to graph all 6 of our trig functions, let's review. So here's the steps for graphing tangent and cotangent. First of all, set your graph up with the correct angle values. So for tangent, you would use these for degrees or these for radians. And for cotangent, you would use these for degrees or you would use these for radians. The next thing you would do is you would sketch the asymptotes at the first and last theta values. Then you'd plot your midpoint at the middle theta value. And then based on that from there, you're either going to go in an upward direction or you're going to go in a downward direction depending on whether you have one of these situations or these situations here. Okay, so that's basically a summary of all the reflections. So your graph will go in this direction if you have a tangent, a negative cotangent, a cotangent of negative x, or a double negative with the tangent. Your graph will go the other way for all of these ones. Okay, and don't forget that when you do these things, the a, the number in front of the tangent or cotangent, is how tall your graph gets stretched. Okay, so that's tangent and cotangent. Summary with all the different reflections in it. All right, now let's revisit sine and cosine now. So this is from a couple days ago now. With sine and cosine, we use these numbers if we're doing degrees, or these numbers if we're doing radians. After that, we sketch the midline. Then we sketch the maximum and minimum. And then we're going to use these charts below to kind of know where to start and where to go. So if you have a sine x or a double negative sine, you start at the midline and go up. if you have a sign with a negative on the inside or a sign with only a negative on the outside, you're going to start at the midline and go down. If you have cosine or cosine of negative x, both of those start at the top and go in a downward direction. Or if you have a negative cosine x or a double negative cosine of x, then you start at the minimum and go up. Okay, so there's all those. And there's not really much to say about secant and cosecant, because basically secant and cosecant is you start by doing the sine and cosine, which we just talked about. After that, you just put vertical asymptotes where the sine or cosine function touches the midline, and then you put your little U-shapes on there. And that's what we learned last class. Okay, so we have a summary of all the different ways of graphing trig functions. There's still more to come, but for now, that's the basic idea for all 6 of them. So we're about ready to do kind of like a summary of these, and so you're going to want to use those charts. So let's begin here. So first of all, notice that I'm going to be graphing a sine function. And since I'm graphing a sine function, we will be using these steps here. So step 1 is to set my graph up with the correct angles. You could use radians or degrees. It doesn't matter. So let's go ahead and just do degrees this time. So for number 1, the degrees are going to be 0, 90, 180, 270, and 360. Okay? What's next? Step 2 says sketch the midline. So this number right here is my midline. So I'm going to put a 1 right there, and we're going to draw a dotted line all the way across for my midline. All right? Now what? Sketch the max and the min. So we have to remember how to do that. The way you get your max and min is by taking your amplitude. Now there's no number here, so that means that my amplitude is 1, and you add that to your midline. So if I'm at 1 and I add 1 to it, that gives me my max. And if I subtract 1 from it, that gives me my minimum, which will now be a 0. I did green there just so you could see the difference since it's right on top of the axis. All right. The next thing we're going to do is, let's see. After you sketch your max and min, you're going to use the chart below to figure out where to start and where to go. Now, as you guys can see here, I've got a negative sign. There's no negative on the inside, just a negative in the front. So when that happens, that's this one right here. And so my graph is going to start at the midline and go down. So I'm going to start at the midline. And then I'm going to go down. So down, and then I bounce back up to the midline, then back up to the max, and then back down to the midline. And there's my sine wave. Now, we could just stop there if you want, but technically it does kind of keep going, right? But I'll just leave it at the basic shape for now. So that's number 1. Let's go ahead and do number 2. So for number 2, I've got a cosine function. So once we're actually going to be using the same steps here, so we're going to set up our graph. I'll do radians this time just to change it up. So for cosine, using the same steps as last time, you're going to set up your graph, and we're going to do radians this time though, just to change things up. So pi over 2, pi, 3 pi over 2, 2 pi. All right, so that's step 1. Let's go ahead and take a look at step 2. Sketch the midline. My midline in this case is -2. So I'm going to go down 2, and I'm going to put a dotted line there. And there's my midline. Let's go ahead and take a look at step 3. Step 3 says to sketch the max and the min. So how do we sketch a max and min? We take the amplitude, which is 3, and we add that to the midline. So my midline is -2, so I'm going to go up 3. 1, 2, 3, and down 3. 1, 2, 3, and that will give us our max at 1 and our minimum at -5. All right, what's next? Now we use the chart below to find where to start and where to go. So on this one, I've got a negative in front of the cosine and a negative inside of the cosine. So a negative in front and inside will be like this one, where we start at the minimum and go up. So I'll start at the minimum, and then I'll go up from there. Midline, max, midline, minimum. And there's my graph. And once again, it does keep going, but I think I'm just going to go ahead and leave it with just the basic shape there. Okay. All right, we'll do one more problem. One more problem. I'm going to actually change this one. Okay, so for this last one, I just changed it from tangent to secant because we haven't done one of these yet. So secant, how do we do a secant? Well, let's go to our steps. So if you're graphing secant or cosecant, the first thing we're going to do is we're just going to basically use the steps for sine and cosine. If it's a secant function, which it is, we're just going to follow the steps for graphing cosine. And so we're going to go ahead and go back again to these steps. We're going to do all of this first, and once that's done, we'll come back and do steps 2 and 3 to finish this one up. Okay, so we're going to graph cosine. So this time I'm not going to go back and forth to the steps just because it's really the same steps as the other ones there. So here we go. So we have, I'm going to be graphing 2 cosine of -x. So here we go. Make your graph. The angles for cosine are 90, 180, 270, 360. Now there's no there's no midline on this one. That means my midline is 0. So I'm going to be sketching a midline here right on the x-axis. My amplitude is 2, so I'm going to be going up 2 and down 2, and I'll sketch my max here. I'll sketch my minimum here. Next, whenever you have a cosine with a negative on the inside, that one starts at the maximum and then it goes down. And here's our cosine graph. Now for this one, I am going to go ahead and continue the pattern a little bit because it just makes the secant graph look a little cooler that way. So now that we've completely finished graphing the cosine function, now we're going to move back into graphing the secant function. So how do we do that? Let's review with our secant steps here. So step 1, since we had a secant, we just graphed a cosine function. Now step 2, we're going to put vertical asymptotes where the cosine function touches the midline. So let's do that. So it touches the midline here, 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 and here. So we're just going to draw some vertical lines here. Those are vertical asymptotes. One more step to get the secant function graphed. Now we're going to place the little U-shapes in there at the peak and trough of each curve. So let's do that. I'll do that one in hot pink here. So we're going to have a U-shape there, a U-shape here, 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 and here, and here. All right, and there you go. Now technically, none of this is really a part of the graph. You don't need the cosine graph at all on there. I'll get rid of all the beige too. So basically, it's just these U-shapes, just these pink U-shapes, and you can also include the vertical asymptotes as well. But there it is. All right. So that is a secant graph. So there you guys have it. So let's go and do a student practice here. I only have enough space to put one up at a time. So pause the video here, try number 1, and when you unpause it, I'll have the answer up for you guys. All right, guys, so there's our answer number 1. So now when I'm grading this, what are some things I'm going to be looking for, like on a quiz or something, whenever I grade these things? Well, first of all, I'm going to want to make sure that I see the correct angles down here at the bottom. That would be one thing I look for. Another thing I would look for is I would like to see if your midline, your max, and your min are located in the right spots. Your max should be at 3, your midline should be at 2, and your minimum should be at 1. And then finally, I'm going to look at your starting point. Did you start at the right spot? And after that, did you have the correct shape? So I'm looking at a lot of stuff. That's 1, 2, 3, 4, 5, and then 6 for the shape. So I will pretty much be breaking these down into 6 points and looking at each one of those things whenever I grade your guys' graphs of these trig functions. All right, so go ahead and pause the video here and graph number 2 and see what you guys get there. All right, so this is what your graph should have looked like on number 2. Did you get the angles right? That's plus 1 point. Did you have your vertical asymptotes on there? That's plus 2 points. Did you get your midpoint in the right spot at 0, 90? That's another point. Did you get your other 2 points correct? One is at 45 and up 3. The other one's at 135 and down 3. That's another point. And then the basic shape. So all those things are what I'm looking for. Let's go and do one more here. And let's try number 3. So go ahead and pause the video here. Graph number 3. When you unpause it, I'll have the solution up for you. Okay, and there's our answer number 3. So let's check our work. First of all, did you use the correct angles? Next, your midline should have been at 1, your max should have been at 3, and your minimum should have been at -1. Your first point that you plotted should have been right here at 0, 1. And then from there, we should have went in a downward direction to create this basic sine shape here. Okay. From there, you just continue the sine shape, and then draw vertical asymptotes. Did you have vertical asymptotes where the sine function touches the midline? And then finally, did you put your little parabolas in there, which is really the actual graph. And that's it. So that'll do it. So hopefully that was helpful, and we'll see you guys in class to practice this stuff some more. Till then, have a good one.